So this is the last topic of module 4, that is instrumentation amplifier. So here in this topic we will discuss how an op-amp can be used as an intermediate stage between the input and output stage. Okay, so here we will discuss one by one. So input stage is nothing but it contains a transducer plus with preamplifier. So this input stage, it takes the physical quantity which is need to be measured, and that physical quantity is converted into another form of energy. For example, like you can take a light, okay, or you can take a force, or you can take a pressure. So all these physical quantities can be converted into the electrical energy. So that is the role of transducer, which is used in the input stage. Okay, then the output of this input stage like transducer is given to the intermediate stage. So intermediate stage is made up of operational amplifiers called as instrumentation amplifier. So here it is used to measure the input stage or the output provided by the input stage. Then it is given to the output stage. So output stage acts as an indicator, so to indicate the output. So here in the output stage we can use a CRO or any LED lights to display the information. So this is about the block diagram of an instrumentation system. Okay, so now we will take an equivalent circuit for this and discuss these input stage, intermediate stage and the output stage in terms of internal circuit diagram. Okay, so now, so this is the explanation of what the above basic block diagram. Just go through it, you will understand. So very simple one. Now, so this is important. So this is the internal circuit diagram of an instrumentation amplifier. So here we call it as differential instrumentation amplifier using transducer bridge. Okay, now so we'll categorize this as an input stage, intermediate stage and the output stage. So here this bridge we call it as an input stage. Okay, this op amps we call them as intermediate stage, and this meter we can call it as an output stage. Okay, so now what is in the input stage now? So now look at the input stage. It consists of one bridge, so I call it as a Wheatstone bridge. So I think we already discussed Wheatstone bridge in electronic devices lab also. If the bridge is said to be balanced, then we can say that RC by RB is equals to RT by RA. So I will tell what are all these things if the bridge is balanced. Okay, so here first we'll focus on the input stage, then we'll focus on the intermediate, the last in the output stage. Now look at the input stage. It has one bridge. Okay, VDC is the input signal. Okay, RC, RB and RA are the fixed registers in the bridge, and this is only one register which is variable. So this register we call it as a transducer resistance. Okay, so that's why it is written as RT plus or minus change in R, means this can be changed physically. So based on changing this register we can balance the bridge. If the bridge is balanced, then we can say that RC by RB equals to RT plus or minus change in R divided by RA, or simply RT by RA. So then we can say that the bridge is balanced. So here this resistor acts as a transducer which allows to change the physical quantity. That physical quantity is applied at the RT resistor, then it is converted in terms of electrical signal using this bridge. Okay, now another important thing at this bridge is here two voltages are there. One is VA, another is VB. These two acts as the input voltage for the op amps which are connected here. Okay, and these input voltages depends on the resistors and the applied voltage which is VDC here. So now, so what is the value of VB? So this circuit looks like a voltage divider circuit like VB. So from VB the resistance RB is connected to ground. So now this acts as an output side. Okay, from VB resistance RC is connected to the input side and again it is connected to ground. So this one circuit which looks like a voltage divider circuit, where the value of VB depends on RB into VDC divided by RC plus RB.